Hello everyone, and welcome to my channel. This is an educational channel, and we focus on shedding light on some great theories of everything, cosmologies, all-encompassing theories, paradigm shifters, anything that could benefit your overall holistic worldview and help you to make transitions in your life to adapt to the new coming 5D reality, and so on. Today is our 413th video on the reciprocal system of theory from Dewey B. Larson. And Mr. Larson in 1959 proposed his two fundamental postulates, just two sentences that he had boiled down, condensed from all of his research and findings from the 30 years before. And they purported to tell how the universe operated. He then took those two fundamental postulates and through a process of deduction, if this, then that, he derived his theoretical universe. This is what my universe would look like if my postulates were correct. And then in a lot of his books, he compared his theoretical universe with the measured empirical universe of legacy science, the universe that they had arrived at through experiments in their laboratories and compiling these things in tables. And we're looking at one of Larson's books that he put out in 1987, just a couple of years before he died, called Basic Properties of Matter. And this book is on chemistry and primarily. And so Larson kind of derives his theoretical universe of chemistry, and compares them with the scientific tables. So this first chapter that we're looking at is called Solid Cohesion. He develops some equations for different aspects of chemistry, like melting point, boiling point, specific heat, interatomic distance, and compares them with the tables. Now, we've been struggling going through this chapter because there's a lot of background information that he covers in other books and other chapters that you need to refer to, or at least for a more thorough explanation. He gives kind of a cursory explanation in some places here. But bear with me, and we're going to move through this slowly, and we're going to work it out. You can also go back and look at some of the older videos that I've done where these things are explained. I did 15 videos on his deductive development of the reciprocal system about a year ago. And about 6 months ago, I did many dozens of videos on his book Nothing But Motion, which is the first volume of this 3-volume set, of which Basic Properties of Matter is the second volume. And so you can look at those. In the long run, hopefully I will be able to integrate all these things together, probably by watching my own videos and putting it together so that I have it all on a silver platter for you. But right now, I'm struggling myself to figure out the reciprocal system I'm not able to put it on a silver platter for you. I'm just trying to put it out there so that you can get it if you are astute and you are willing to do the work. It's out there for you. At some point, I'm going to try to get, put it on a silver platter for people so that they don't have to work that hard to get it. It's never going to be easy. It probably never will be easier than your high school chemistry class. But that's pretty easy, Was that 50 minutes a day for a year? 180 days. So, that's not a huge investment to learn how the whole universe operates, if Larson is correct. but I would recommend that you just don't dismiss his work because a couple things didn't satisfy you in terms of the explanations. Turns out Larson's pretty darn consistent about things. So, getting back to the fundamental postulates, the first postulate, which is by far the most important, the more important, is that the universe is composed entirely of one component, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. Paraphrasing shortly, the universe is not made out of matter or energy or anything else. It is made out of motion. And motion is the relationship between space and time. Space and time are reciprocals of one another. Basically, motion is a fraction with space or time as the numerator and time or space as the denominator. But space and time, both being identical because they are reciprocals, they both have multiple dimensions. Larson says 3 dimensions, coordinate space and coordinate time in a still frame. Now that is what he observed about space, and he extrapolated to time. And when Larson refers to motion, he's referring to a specific kind of motion, or more generalized kind of motion, called scalar motion. This is a non-localized motion that has a magnitude but has no direction, which you can envision using a balloon with dots on it. If you blow up the balloon, all the dots are moving away from each other. But every dot is moving away from every other dot. They're not moving in any specific direction, or rather they're moving in all directions. And then if you suck in the balloon, all of the dots will be moving toward each other. And it will look like the force of gravitation, but it isn't, because every dot is moving toward every other dot. But if you stop the universe and you basically arbitrarily assign a reference point, you say one dot is motionless, then it appears as if there's an action at a distance and that there's a force field between your reference dot and each other dot considered in isolation. So Larson calls that an as-if force. Now also there is what he calls the discrete unit postulate. Space, time, and motion come only in discrete units. You have to have a full unit of space and a full unit of time in order to have those entities. And if you have exactly 1 unit of space in 1 unit of time, space over time being speed, the car is moving 10 miles per hour. And if you have 1 unit of space and 1 unit of time, you have the speed of light. The speed of light is the background speed of the reciprocal system. And so half the universe is moving faster than the speed of light, and half is moving slower. The speed of light is the boundary between 2 different sectors of the universe, only one of which the legacy scientists are aware of, which Larson calls the material sector. That part of our universe that's moving slower than the speed of light. The half that's moving faster than the speed of light, Larson calls the cosmic sector. And that has to do with antimatter, or what Larson calls cosmic matter. And then also, so that there is a boundary there between the 2 different sectors, which is the speed of light. So if you have a universe with nothing in it, you still have outward motion at the speed of light in all directions. A scalar motion outward in all directions at the speed of light is what Larson calls the progression of the natural reference system. And then on one side you have the cosmic sector, on the other side you have the material sector. But within the cosmic sector and the material sector, there are 2 more boundaries that have to do with the discrete unit postulate also. One is within where the interactions are occurring within 1 unit of space. Another is within 1 unit of time. The first in the material sector, the second in the cosmic sector. In the material sector, if you don't have a full unit of space, then you do not have space, because you have to have a full unit. So you only have time, because everything is either space or time or both. And so if you don't have space, you have time. Larson calls this the time region. And this is the region of atomic and molecular interaction that occur within 1 unit of space. And the rules change when you cross that unit space boundary. Same is true of the unit time boundary in the cosmic sector. If you don't have a full unit of time, you have only space. And so Larson calls that the space region. And that is the realm of cosmic atoms, interactions of cosmic atoms and cosmic molecules. These two sectors, the material and cosmic sector, are reciprocals of one another. So even though we only know anything about the material sector, we can extrapolate to the cosmic sector. In the material sector, we have interactions based on coordinate space, 3 dimensions of space in a still frame, and clock time. The clock is always getting later and later and later, but in no specific directions, like a scalar motion. And in the cosmic sector, when we cross the speed of light boundary and move into the cosmic sector, then we have relations based on coordinate time, 3 dimensions of time in a still frame, and clock space. Space is always getting later, and space is always getting farther and farther and farther apart, like on a surface of an expanding balloon. Okay, now we are in the first chapter here, solid cohesion, and we just, this is about the 9th day of doing this, and so if you want to go back to the beginning, you want to go back about 8 videos. But Larson just got done kind of comparing his equation or his expression for specific rotation to the legacy scientists, and it looks like in all 4 of the measurements, he's, well, 3 of the 4 measurements are within 1%, and the other one is off by about 2%. Okay. A few of the experimental data have been extrapolated to this 0 base by the investigators, but most of them are the actual observed values at atmospheric pressure and at temperatures which depend on the properties of the substances under examination. These values are not exactly comparable to the calculated distances. In general, however, the expansion and compression up to the temperature and pressure of observation are small. A comparison of the values in the last 2 columns of Table 1 and the similar tables in chapters 2 and 3 therefore give a good picture of the extent of agreement between the theoretical figures and the experimental results. Another point about the distance correlations that need to be taken into account is that there is a substantial amount of variation in the experimental results. If we were to take the closest of these measured values as the basis for comparison, the correlation would be very much better. One relatively recent determination of the xenon distance, for example, arrives at a value of 4.34, almost identical with the calculated distance. There are also reported values for the argon distance that agree more closely with the theoretical result. However, a general policy of using the closest values would introduce a bias that would tend to make the correlation look more favorable than the situation actually warrants. It has therefore been considered advisable to use empirical data from a recognized selection of preferred values, except for those values identified by asterisks. All of the experimental distances shown in the tables are taken from the extensive compilation by Wyckoff. Of course, the use of these values selected on the basis of indirect criteria introduces a bias in the unfavorable direction, since if the theoretical results are correct, every experimental error shows up as a discrepancy But even with this negative bias, the agreement between theory and observation is close enough to show that the theoretical determination of the interatomic distance is correct in principle, and to demonstrate that, with the exception of a relatively small number of uncertain cases, it is also correct in the detailed application. So really, Larson is kind of saying that, there's a lot of disagreement among the empirical scientists. Different laboratories are coming up with slightly different results for these values as well. And so Larson is saying, I'm going to stick with this table from Wyckoff. Wyckoff is the one that I'm going to be using, even though some of the results that come from other laboratories and other authors match up better with the numbers that I derived. And so, he's kind of saying that, look, I'm not getting the exact values that Wyckoff is getting. My numbers are coming strictly from theory. Okay, this is coming from an equation that I derived strictly from theory. I'm not getting the exact results that Wyckoff is getting, but I'm getting very close results to what Wyckoff is getting. And the other chemistry laboratories in the country that are also doing these same tests and evaluations and compiling tables are also not getting the same values as Wyckoff. There's a slight discrepancy that's just in the nature of the laboratory business, more or less. Turning now to the elements which have electric as well as magnetic displacement. We note again that the electric rotation is one-dimensional and opposes the magnetic rotation. Okay, now the previous values that he derived were for the noble gases, the inert gases that have a 0 for their third number. All of the atoms come in. Instead of using just one number from the periodic table, Larson uses a 3-number set. When you're talking about the atomic periodic table, the atomic number is generally the amount of protons and electrons. Larson doesn't go that way. Larson is measuring in terms of motions, really rotational displacements. He uses displacement because where the scientists are measuring from 0 motion, Larson is making his measurements from the progression of the natural reference system, from unit speed. So it's not, Larson is not necessarily measuring motion. He's measuring motion displacement. How much is this motion different from the motion of the speed of light outward in all directions? And Larson's 3 numbers, the first number is the primary magnetic 2-dimensional rotation. Every atom is a set of rotations. That's what's, at first you start out with 2 photons at the center of the atom. And then those photons are rotated. So it's kind of like a knot. The 2 photons are moving outward at the speed of light in all directions because they are basically not moving. They are basically on the surface of that balloon and are moving outward at the speed of light in all directions. That's why they're always measured at the speed of light. But you slow down the photon by rotating it. And you have to rotate it really 3 different ways, 3 different dimensions. The universe is 3-dimensional, according to Larson. 3 dimensions to stop it and then basically turn it into matter or atoms and to make it subject to the as-if force of gravitation. So the first motion is a two-dimensional primary rotation. The second number is the secondary two-dimensional rotation. And the third number, like he says here, is the one-dimensional rotation that is what he says opposes the magnetic rotation. And this third number is only applicable for all of the non-inert gases, the non-noble gases. So those 6 noble gases have a 0 for their third number. All of the other elements have a number plus or minus integers, 1, 2, 3, 4, 5, for that third number. For example, oxygen element number 8 on the periodic table, its 3-number set is 2 primary magnetic rotations, two-dimensional rotations. Magnetic and is in Larson's system is basically synonymous with two-dimensional, and electric is not synonymous with one-dimensional. So oxygen is 2 primary two-dimensional rotations, 2 secondary two-dimensional rotations. And remember, those 2 numbers alternate. So as you move up the periodic table, you know, these are really like the rows of the periodic table. So every element on the same row of the periodic table as oxygen, those first 2 numbers are 2 and 2. And then the next row is 3 and 2. Okay, that row would be, you know, the row with sodium and phosphorus and silicon. Okay, that would be 3, 2. And then the next row would be 3, 3. And then the next row would be 4, 3. And the next row would be 4, 4. Okay, so, and then the third number, the electric rotation, is really the distance from the noble gases. So basically like the electric ionic valence. So oxygen being 2 less than neon. Neon is the noble gas on that row, number 10. Oxygen is 2 from that, but it's 2 minus from that. So oxygen's 3 numbers are 2, 2, negative 2, which Larson notates by just putting a parenthesis around it instead of saying negative 2, because he's using dashes all over the place, and so another dash for a negative sign would be confusing. So he just uses a parenthesis to denote negative 2. Okay, so now Larson is going to get ready to calculate the specific rotation for those atoms that are not in the noble gas series. So that's basically what he just said with that sentence. We may therefore obtain an expression or equation for the effect of the electric rotational force on the magnetically rotating photon by inverting the one-dimensional force term of equation 1, 2. Now, equation 1, 2, if we go back, oh boy, sorry, I can't go back. Okay, we'll figure it out. But given that the one-dimensional rotation is opposite or opposing the magnetic rotations, he's saying that we invert, okay, expression for the effect of the electrical rotational force on the magnetically rotating photon by inverting the one-dimensional force term. Okay, so he calls it the force of the electric rotation is 1 over log of t a natural log ta times log of t natural log natural log of TB. Now there's an apostrophe there, and I don't know if that's supposed to be a squared, which would be log squared, log of t squared a, log of t squared b. We'll have to figure that out as we move along here. Doing Larson, following his work, is very much detective work. You have to kind of, a lot of times, okay, it could be this, or it could be that, or it could be this. We got to keep going, keep moving on until Larson will explain it someplace later. You'll get the clue eventually, and you'll be able to figure it out. You kind of have to go back. That's the only way to learn this stuff. And that really applies to all esoteric studies. Anytime you're studying anything esoteric, you have to be a detective. You know, it's not there for you, and the infrastructure is not there for you either, because, you know, the work is, they're attempting to suppress the work. So, you know, the powers that be are attempting to suppress this. They don't want you to learn it, so they're going to put up every obstacle for you to not learn it. And so in order to actually learn it, you have to dig, and you have to be a bulldog, and you have to be a detective. Okay, so we will figure this out, but let's just move on. Inasmuch as the electric rotation is not an independent motion of the basic photon, but a rotation of the magnetically rotating structure in the reverse direction, combining the electric rotational force of that last equation with the magnetic rotational force of equation 1,4 modifies the rotational terms only, and leaves the remainder of that 1,4 equation unchanged. So force equals 0.006392, which is the interregional ratio, which is basically the amount that's lost in the translation from looking into a different region of the universe, in particular here, looking into the time region. Anytime we're looking into the time region, we have to reduce the value by that fraction for an atom, 156.44, which is 128. It's 2 to the 7th power times 11 over 9, which he derives in his book Nothing But Motion, and in a separate paper also that I also went over. So if you want to look at that, it's called the interregional ratio. So he takes that interregional ratio to the 4th power. So that's an extremely small number. 156 to the 4th power is the amount that you have to reduce the result by. Times log squared of t, so it was log squared, natural log squared ta times natural log squared tb over space to the 4th power, so 1 unit of space to the 4th power times, oh, okay, so maybe it wasn't log of t, because still we have these apostrophes here. Log of t apostrophe a natural log t apostrophe b. Here again, the effective rotational or outward and natural rotational because outward, because gravitation is moving outward in the time region. The progression moves outward in the outside region in the material sector, and gravitation moves inward. But when you cross that unit speed boundary, then the directions invert, and gravitation is now outward toward 1 unit of space, and gravitation and the progression is inward toward 1 unit, toward 0, away from 1 unit. So the progression is always moving away from unit space, and gravitation is always moving toward unit space. Here again, the effective rotational or outward and natural reference system progression inward forces are necessarily equal at the equilibrium point. That's where he's determining that this interatomic distance is occurring, at the equilibrium point, where those two forces are equal. Since the force of the progression of the natural reference system is unity, we substitute this value for F in that previous equation and solve for S sub 0, the equilibrium distance as before. So S sub 0, or the equilibrium distance, equals 0.006392, the interregional ratio. I thought that was supposed to be taken to the 4th power, but that number isn't there right now. Times log to the 1/2 TA times natural log to the 1/2 TB over log to the 1/4 T apostrophe A times log to the 1/4 T apostrophe B. Okay, so I believe that is due to some algebraic maneuvering. I'll look into that, how that equation comes about, and maybe I'll have some answers for the next video. But just bear with it, you know. There are great rewards that will be awaiting you if you persevere and get through this. Me too. I mean, I'm obviously not an expert in this, but I have some familiarity with it just from bulldogish exploration. And I know that I've gained great benefits from understanding the reciprocal system to the very limited extent that I do. And I also know that it's a great investment because eventually, whether it's in my lifetime or not, everybody will need to know the reciprocal system because it will be the basis for all science and liberal arts and really all subjects for everything. It's a theory of everything. So it will be the basis of all academic curricula forever from now on, as soon as it catches hold, as soon as people figure out that it's correct. And I'm not saying that Larson is correct about everything, but the theory itself is correct. I'm convinced of it. So it's a great investment. Get in and buckle down. All right, thanks. Have a great day.